Okay, I want to do the solution for question number 1 on the calculators allowed part. I was kind of hurrying through in class. I decided to re-record this to make it a little bit less frenetic, to say the least, and a little bit more understandable. Okay, two forces are applied to a metal ring as shown below. The angle between the forces is 100 degrees. Find the magnitude and direction of the force needed to bring a system to equilibrium. In other words, this was just like our problem that we did on the force table. So let's take a look at this. We don't know, we could set the coordinate axis here so that would make our life really easy. We don't have to have the coordinate axis. It's not really given here. But for the sake of our discussion, I just said let the 20 Newton force be at 0 degrees. And then we can figure everything else out. And we're allowed to do that. We could make it at any angle, but why not make our life pretty easy? So anyway, that being said, this is at 0 degrees, 20 newtons. So then our vector representation of this, force number 1, is 20 and 0. Or we could write force number 1 is equal to 20 I hat plus 0 j hat. That's our unit vector notation. Now let's get force 2. Now, this force 2 is in quadrant number 3. So our sine value and our cosine value will be negative. So let's go ahead here and take a look. I'm going to go into 15 times the cosine of 60. 260 rather. 260. And that's negative 2.6. And these are newtons, by the way, for our units. And the other one is going to be 15 times the sine of 260. And that's negative 14.7. So those are our components for that vector. And now, let's add them up. So let's call this the resultant force of these two. And then we'll come back to the vector where we need to go in just a moment. So the resultant force is going to be 20 plus a negative 2.6, which is 17.4, and 0 plus a negative 14.7, negative 14.7. And that is our component of our vector. Now let's see where that is in the plane. I'm going across 17 and down 14. So my vector is going to be somewhere down here. And again, if we were to draw a parallelogram and say this vector, this is in inches, that's 10 inches. So if I drew a parallelogram, this is the pictorial method of 10 inches. What did I say it was? Yeah, 10. And another vector this way to do that parallelogram method. Well, notice we would expect our resultant force to be right down there, right down there, with an angle certainly below the x-axis. So our force that we have to find is the force that counterbalances that force in order for our system to be at equilibrium. Well, let's go ahead and do that. First things first, let's go ahead and find the magnitude or the norm or the length of that vector, the length. So we do that by using Pythagorean theorem. So we're going to say the norm or the length or the magnitude, they all mean the same thing, of that vector is going to be 17.4 squared plus negative 14.7 in parentheses squared. So we're going to go ahead and do that and come up with a value. So we've got 17.4 squared plus 14.7 squared, and the square root of that is 22.8 newtons. So the value of that is 22.8 newtons. Okay, very good. Now that means that we have to apply the force of 22.8 newtons in this direction, opposite of that. But now we have to find the angle. Okay, so what is that angle going to be? Let's take a look and see here. Now, what we know is that, let me go ahead and sort of erase this parallelogram so I don't make the issue confusing. any more confusing than it might already be. So let's go ahead here and sketch this out. Well, we know our x component here is 17.4. We know our y component is 14.7. So we can get the tangent of this angle right here. Okay, the tangent of that angle is going to be set. The angle is going to be the inverse tangent of 17.4 over to 14.7. And we could also do it there as well. We're going to find the complementary angle. So the inverse tangent of 17.4 divided by 14.7, that's 49.8. So let's call that about 50, right? So if this angle is 50, this angle here has to be negative 40 degrees. All right, so what that means is this angle here has to be 40 degrees above there, or 180 minus 40. So this angle here is going to be 140 degrees. So that's where we want to put our resultant. The vector that counterbalances that. So 22.8 newtons, 140 degrees above, as measured from the positive x-axis. So that's the first question. I'm going to load up each question separately, and as I get through tonight's conferences, I should have them all up for you.